Can you guys comment now? Why is it like this? Good evening, Precious. Welcome in, Precious. My people can comment now. Good evening, Jai. Sorry. I just the see chat. Good evening, Emmanuel, Precious, Favor, welcome in. Prince, welcome in. Emmanuel. Yeah, Iceman. Alright, let's start. So, are we already? Good evening, Emmanuel. Good evening. Are we already, or we should wait a little bit? Should we start, or we should wait a little bit? Should we start, or we should wait a little bit? We should wait. Alright. So pending the time, please screenshot what is on the board. Then I will explain and we'll solve examples. So this one is part of your work, maximum and minimum. This one is part of your work, maximum. So we'll just do little things under differentiation and we'll go to integration. So we'll just do little things under differentiation and we'll move to integration. So, but can we all see the board? Is it clear? Can we all see the board? Is it clear? Can we all see the board? Is it clear? Is the board clear? Okay, done. I think people don't know you are live. Yeah, they don't know. Don't worry, they don't know. Okay, it's clear, right? Alright, let me just explain what's on the board before time will go. Yes, okay, let me explain what's on the board. Then we'll solve examples. So this is maximum and minimum points. Now, under this guy, there are two different things I will explain. And what are the things am I explaining? I'm going to explain maximum and minimum points, and I will also explain maximum value and minimum value. They are two different things. Maximum point and minimum point is different from maximum value and minimum value. Do you get it? So in the exam, look at the question very well. If they ask you, it's part of your syllabus, so this one is even part. So this one is part. So in the exam, when they ask you to look for the maximum point, the maximum and minimum point, if they ask you to look for the maximum and minimum point, how will you solve it? You have to follow this step. But if they ask you to look for the maximum and minimum value, there are two different things, so please take note. Two different things, please take note. It is not clear again. Are you sure? I'm coming. Hold on. What about now? Is it better now? Moji, is it better now? Is it better? Yeah, point. Okay, is the person network? Oh, alright. So is it better now? Okay. So points, yeah, someone is saying point is different from what? So point is different from value, yes. So when they ask you maximum and minimum point, it's different from what? Maximum and minimum value. Take note too, but it's still the same procedure. So let me just explain this and we'll solve just one example. Just one. Then we'll do other things on differentiation, we'll go to integration. So maximum and minimum point. These are the steps. Points is different from value. When they say point is the point, maximum and minimum point is different from maximum and minimum value. That's what I mean. So what are the steps? The first thing is to what? Find the first derivative of the curve. The first thing is to what? Find the first derivative of the curve. What's the derivative of the curve? The derivative of the curve is what? You have to find dy dx. That's the first thing. You differentiate once. Sure you get. It's blurry. It's not blurry now. It's not blurry. What happened? It's not blurry now. Huh? It's not blurry. So let me just continue. Check your network. It's not blurry. Now, the first thing is to define the derivative of the curve. Then the second one is what? You equate your dy dx to 0. Sure you get. So you equate your dy dx to what? To 0. Do you get? That's the next thing. Then the third thing is to what? Find the second derivative. Good evening everyone. Good evening. All right. So the second thing is the third thing is to find the second derivative, meaning you have to differentiate the second time. That's the second and the third thing. Then the fourth thing, substitute the value of x into the second derivative. Now the value of x you got here, you put it inside the second derivative. That one will now determine your maximum and minimum point. Do you get? That one will now determine your maximum and minimum point. So that is just how that thing is. So that is just all on that. So are we all clear now? So but you take note of something. How do you get the maximum point and the minimum point? Just in case they ask you to look for maximum and minimum point. How do you not get it? If your second derivative, when you have put the value of x inside, if it is less than 0, then that's the what? That's the maximum point. If it is greater than 0, then that's the minimum point. But if it is equals to 0, then that's the point of inflection. We call it the stationary point. If your dy dx, that answer you get is equals to 0, that's what you call the stationary point. If it is less than 0, then that point is the maximum point. That one is the maximum point. So in case if they ask you to ask, if they are asking for the maximum point in the exam, so when sure you get, you can't see well. On my blow, what happened now? Is it the reflection of the light that is too much of it? What about now? Is it blur? Is it still blur? Check now. Why am I not getting this thing today like this? It is not now. So I don't know what is happening. Check your network now. I should continue. Please now, please don't drag us back. But make sure you are checking it. But probably okay. So please, now that is just that. If it is less than 0, that's the maximum. They can ask you in the exam. You see this thing I just give you here. They can ask you in the exam. They can say if the square y over the x square is less than 0, what is that point? You should know it is maximum what? Maximum point. This is another question here. Take note to share you get. This is another question here. If it is less than 0, that's the maximum point. They can ask you this kind of question in the exam without solving itself. They can ask you. Do you get what I just said now? Do you understand what I just said now? Do you understand? Yes, all right. So now if it is less than 0, that is the maximum point. They can, these things I'm giving here is a question on its own. If they ask you that if the square y over the x square is less than 0, what is that point? You should know it is maximum point. If it is greater than 0, you should know it is minimum point. If it is equals to 0, you should know it is point of inflection, or you can call it what? Stationary point. Do you get? So this part you are seeing here is also a question. Now let's say they ask you for maximum value and minimum value. How do you get maximum and minimum value? You substitute the values of that x which gave this condition. the value of this x which gave you this condition into the curve equation. You put it inside the curve equation, inside the main question, to get the maximum value and the minimum value. So that is just that about that. So let's solve example. So screenshot, if you have not screenshot, then we solve example. So screenshot, then we solve example. Now, yeah, let's already up and screenshot. Then we'll solve examples. Can I continue? Good evening, everyone. Can I continue now? To get the value, we have to substitute for derivative of x in points. No, if you want to get the value now, well, I will still solve it. If you want to get the value now, you have to now, you see, the x, the condition you have here, you have to put it back inside the main curve. That is how you get value. Don't worry, we will solve questions. Can I clean? Good evening, everyone. Welcome in. Now we have a lot of people. So screenshot, please, before we solve one example. Screenshot as you are coming in. Screenshot. Good evening, Eniola. Good evening, Chooks. Good evening. Screenshot before I clean. Please screenshot. Then we'll solve examples. Just one. Okay, don't worry. When I solve one, but make sure, don't worry. You shall see, the first thing is to what? We differentiate. Put these things in here. The second thing, we just equate our y. There's no, the board can't contain it. I would have not cleaned it and solved question. I would have not cleaned it. The board can't contain everything, that's why. If I say I should solve one question down now, it's not contain it. So, oh yeah, can I clean now? Can I clean? For those that just come in, welcome in. Can I clean now? This is maximum and minimum point. Oh, you might come across it in the exam. And this part is also a question. You see these 3 parts like this is also a question. They can say when the square y over the square is less than 0, what point is it? It is the maximum point. If it is greater than 0, it is called the minimum point. If it is equal to 0, it is called the point of inflection or the stationary point. Please. Alright, so I can clean now. YouTube did not allow us to screenshot. Are you sure? Wait, let me try. How come? You can screenshot now. It's there now. You can screenshot. You can screenshot. How are you doing it? Yeah. You can screenshot. Just do it and screenshot it. Hurry up. Then we'll pick one example. Are we ready? Alright. So let me clean it. Then we'll solve one example. Now look at this question now. Let's say in the exam they ask you this kind of question. They might not ask you for the 3 example, but I just solving just one. They might not ask you for the 3. They just say, okay, find. They said find the stationary. Find the stationary minimum and maximum point. Find the stationary minimum and maximum point on the curve. So when you see questions like this, don't be scared though. On the curve whose equations is y equals to x cubed over 3 plus x squared minus 3x plus 4. Now look at the question. How many of you have come across questions like this? Probably in your past question. How many of you have come across questions like this? Yeah. It's differentiation and we just want to finish it. If I say I did not finish this part now, you might not get it. Sure you get. It's differentiation we did yesterday. So if I say I should skip this part, what if they now ask you question? If you check the syllabus, have you not seen something like maximum and minimum point? Yeah. So in the syllabus, how many of you have the syllabus? Have you not seen where they say maximum and minimum point is also part of your syllabus? How many of you noticed that topic? Is it not there? How many of you noticed? Maximum and minimum point. Is it not there? I think it's there. It's not like you think it's there. If it's not there, I can leave it to in past questions. So it's there also. So if it's not there, I can leave it and let's go to integration. Should I just leave it and go to integration? Thank you everyone. Yeah, I just started. Amira, I just started. It is alright. So let's just solve just one example. Now let me teach you now. You don't need to cram those steps I give you the other time. You don't need to cram it. Thank you everyone for the taps. Thank you. You don't need to cram. Can you throw more lights? That's what we want to do. Good evening, Ella. Tina. Welcome in. So you don't need to cram those steps. You see what I want to do, that is how you do it in the exam. Because I'm sure you will come across questions like this. Now, when in the exam and you see questions like find the stationary minimum and maximum point. Don't forget this one is what? Minimum and what? Minimum and maximum point, right? Don't forget this one is what? Minimum and what? Maximum point. Yes, I just started, Jerus. So, what do? The first thing, they say find the stationary minimum and maximum point on the curve. Whose equation is? Now, the equation is y equals to x cubed over 3 plus x squared minus 3x plus 4. This is what you are given. Alright, so this is what you are given. Now, what do you now do? The first thing you do is what? What is step 1? From what you just screenshotted, you know step 1 is what? Find the derivative of the curve. You differentiate. That is step 1. You do what? You differentiate. So whatever they give you, the first thing you do is what? Is to differentiate. Now let's differentiate together. Now, we are doing it together. We all learned this differentiation yesterday. So divide the x. I'm differentiating y in respect to x. Now, yes, so that's what we want to do. We want to find the first derivative. Now, when you have x cubed over 3, if you are told to differentiate x cubed over 3, what will be the answer? If you get this thing, for those that attended differentiation yesterday, if you get it, I will dash you one marker. If they say differentiate x cubed over 3, what will be the answer? If you can get it, I dash you one marker. Shinfon. People sabi people. Hey, thank God say I no put money. Abdulaziz. Thank God that I no put money. Oh. Now, for those that are saying 3x, just listen. This is it. This is how you differentiate it. Look at it. You know, this is 1 over 3x cubed. You know, this guy, x cubed over 3 is the same thing as 1 over 3x cubed. But when you want to differentiate, your x must not be in fraction, so the x is not in fraction. What do we say differentiation is? The power on that x, we multiply the constant here. What is the power on the x? Chat. What is the power on the x? The power on the x is what? What is the power on that x? 3, right? So that will be 3 multiplied by, what is the coefficient here? The coefficient of that x is what? 1 over 3. Then you now say x to the power of 3. Don't forget what we used to say, minus 1. You subtract 1 from it, right? Don't forget we used to say, you subtract 1 from it. So what happened here? 3 times 1 over 3, 3 cancel 3. Then what are we left with? 3 minus 1 is what? 2. So you see that the differentiation of this guy, it is x squared. Do you understand? I mean, do you understand? Do you understand? Do you understand it now? I want us to flow together. Yes, alright, let me clean this one. So now let's go for x squared plus, when you differentiate x squared, this one is easy. Differentiate x squared, what we have? Hey, some people are not getting it. Were you here yesterday? Were you people here yesterday? Differentiation of x squared. Okay, calm down. Let me explain it again. Look at x squared. Look at x squared. I will explain x squared and come back to this guy now. Look at x squared. You know differentiation, the formula for differentiation is x to the power of n. If you are told to differentiate, it is the n, the power of that x will multiply. That will be nx to the power of n minus 1. This is the formula for differentiation. Are you seeing it now? Alright, I know. This is the formula for differentiation. That is the power of that x. We multiply the what? We multiply the constant down, the coefficient here. Then you subtract 1 from that power. Do you get it now? Those that were not around yesterday, do you get it? Before I move on, do you get it now? Do you get the formula? Yeah, alright. So now look at it. What's the power on this x now? What's the power of the x now? What's the power of this x? The power of this x is what? What's the power of the x? The power of the x is what? 2, right? So that will be 2. The 2 will come down, right? You know the 2 will come down. That will be 2x to the power of, you subtract 1 from that power. You subtract 1 from the 2. So what will it give us? 2x, 2 minus 1 will give us 1. X to the power of 1, it is still x. That will give us 2x. So you see that differentiation of x squared will give us 2x. Do you understand this one now? Do you understand how 2x squared become 2x? Do you understand it now? Do you all understand it now? Yeah, alright. So let's go for the next one. I will come back to this one, don't worry. Oh yeah, do for 3x. For those that understand this guy now, oh yeah, do for 3x. What will be the answer? Do for 3x. Chooks now, better you listen. You keep on saying no. I've explained like 2 things now. Why what are you doing that you cannot? So the answer is minus 3, right? So now how do you get minus 3? Look at it. You have 3x. The power on the x is what? Invisible 1, right? The power on the x is invisible 1. For those that did not get it, I'm explaining this 3x now. The power on the x is invisible 1. The power will multiply the coefficient here. That will be 1 times 3. Then what do you say? You subtract 1 from that power. The power is 1. Subtract 1 from it again. Do you get it now? So that would be 1 times 3 is 3x to the power of 1 minus 1 is what? 0. X to the power of 0 is what? 1. That would be 3 times 1, and that's how they get 3. Do you see how they got 3 now? Favor Princess, welcome in. Do you understand how they got 3 now? Yes, alright. Now let me explain this guy back. Let me explain x to the power of 3 over 3. Now look at this guy now. You know this x to the power of 3 is like 1 over 3x cubed. You know it's the same thing. Look at it though. This x cubed over 3 is the same thing as 1 over 3x cubed, right? Yes, Abby. Is it the same thing? You know x cubed times 1 will go back to x cubed over 3, right? Is it the same thing? Yes, alright. So what do we do? What is the power on this x? The power on the x is what? What is the power on the x? The power on the x is what? What is the power on the x? The power on the x is what? 3, right? So that would be 3 times, what is the coefficient here? 1 over 3. Then what do you now do? You subtract 1 from that power. That would be 3 minus 1. 3, cancel 3 here. We are left with x to the power of 3 minus 1 will give us x squared. Do you now understand how they got x squared now? Do you understand how they got x squared? Do you understand it now? Do you understand how we got this x squared now? Yes, all right. So, and you know this one, differentiation of a constant gives us 0, right? You know this one is out. Differentiation of a constant gives us 0. So that one is out already. So differentiation of a constant gives us 0. Now, this is the first step. Yes. So this is the first step. The first step is to find the derivative of the curve. And this is how you have found the derivative of the curve. Now, the next thing is to what? What's the next thing? Rose, listen now. This is the first thing. Find the derivative of the curve. Do you get? Now, the next thing is to what? They said, put your what? Equate your dy dx to what? To 0, right? Equate, yes, thank you. You know the next thing now, you are not cramming, don't cram. The next thing is to just equate your what? You just say put dy dx equals to what? 0. When you put your dy dx as 0, you know here will now be what? 0 equals to x squared plus 2x minus 3. That's what you are going to have, right? The last one called 4. When you differentiate a constant, it gives you 0. Do you get? Rodiat, when you differentiate a constant, it gives you 0. When you differentiate 4, is a constant, it gives you what? 0. So when the next thing is to put your dy dx as 0. This will now be 0 equals to x squared plus 2x minus 3. Alright. Joy Rose, what's your question? Abdulaziz. Thank God I did not even go to TikTok. Or else I'll have many people that don't understand. But x squared, now you can write it and say x squared plus 2x minus 3 equals 0. Sure you get. Which one is y? Why? Why 3 or what? What are you asking? Why what? Why what? Oh, hurry up. No. Why now? Which one is y? From put dy dx equals to 0. Alright. From put dy, the next step, the step 2 for maximum and minimum points now. It has a step, and that's the step I've given before that I told you people to screenshot. The next step is to what? Is to put your dy dx equals to 0. How did you get 0? It is part of the step. It is part of the step. The step is to put dy dx as 0. The next thing, after you have differentiate, the next thing is to put dy dx as 0. So you put dy dx as 0. So 0 equals to x squared plus 2x minus 3. So when you write it, you have x squared plus 2x minus 3 equals 0. Now, what does this guy look like? Now, thank you, Robson. It is now a quadratic equation, right? It is now a quadratic equation. So that is what it looks like. It is now a quadratic equation. Do you get it now? So, rest. So it is now. Now, what do? We factorize. What are the two numbers that we can have that will give us minus 3 and that will give us plus 2? So that is 3 and minus 1, right? So that will be 3 and minus 1. Is that not it? Yes. So that will be x squared plus 3x. Or let's say x squared. Okay, let's use plus 3x. Let's just use it. That's minus x plus 3x, then minus 3 equals 0. So the two numbers are minus 1 and 3. You know, minus 1 times 3 will give us minus 3. Then minus 1 plus 3 will give us 2. You know, when you take the arrow like this, it becomes minus 3x squared. That's minus 3x squared. And when you add, it gives you 2x. It gives you 2x. So you see that minus 1 and 3. So you see that, good. Thank God we all got the stuff. So you take the bracket like this. Then what is common here? Good evening, Favor. Welcome in. Yeah. What is common here? What is common here? In this guy here, what is common? X. So when you bring x out, x in x squared will give us x. Then x in x will give us 1. So this is what we have. Then what is common here? Plus 3. Right? Plus 3 in plus 3x will give us x. Then plus 3 in minus 3 will give us minus 1 equals 0. Sorry, pentagon. So you see that the bracket is the same. Alright, let me calm down. Sorry. Oh yeah, sorry. So what is common here? Here is plus 3. Plus 3 is common. X is not common now. So you are bringing out plus 3. Plus 3 in plus 3x, it will give us x. Then plus 3 in minus 3 will give us minus 1. You know, plus and minus is minus. 3 in 3 is 1. Then equals 0. So you see that the bracket is the same. Then you pick one of the brackets, x minus 1, and you pick the one outside. What is outside? X plus 3. So you pick one of the brackets. Since the bracket is the same, then you pick the one outside, x plus 3. Okay. Do we get it now? Do we get it? How do you people now want to solve this one in jam like this? And it's part of your syllabus. This one is even a very simple question. Alright. So the next thing is to what? Equate this one to 0. Welcome in everyone. You equate this one to 0. Then you equate this one to 0. So when you equate it to 0, you say x minus 1 equals 0 or x plus 3 equals 0. So yeah, x will be equals to what? When minus 1 cross, what will it become? Network no good. Sorry, Rose. Sorry, Joy Rose. Sorry. When minus 1 cross, what will it become? It will become plus 1. Or x equals to. When plus 3 cross, what will it become? Minus 3. Do we get it now? Alright, minus 3. So now, look at it now. We've gotten the value of x. Now, the next step says what? What does the next step say? The next step says substitute the value of x into what? No. Find the second derivative. Is that not the next step? Step 3 says find the second derivative. Is that not what step 3 says? Find the second derivative. Step 3 is find the second derivative. Is that not step 3? Do you get it now? So after you have gotten the value of x, the next thing you do is what? Find the second derivative. Yes. That's the step. Yeah, find the second derivative. Now you come here. You see this dy dx. This is where you find the second derivative. Not this one again. This is where you find the second derivative from here. This is where you find the second derivative. You see that we have differentiated this guy once. Now to get the second derivative will now be from here. Second derivative will now be d square y over dx squared. That is, I'm differentiating the second time. Now let's differentiate this guy. Differentiate x squared now. All of us know how to do that one. Differentiate x squared. You need to type something. Type. Let's know that you understand differentiation. Differentiate x squared now. What will you have? This can be jam. It's part of jam. I'll tell you. It's part of jam. So differentiate x squared, what will you have? You need to differentiate something. It's not 4x, so Anna. Amira, it's not 4x, so I told you now 2 come down, subtract 1 from it. That will be 2x to the power of 1. That's 2x now. So that will give us 2x. Then plus differentiate 2x. This one is very simple. I said it yesterday. Differentiate 2x. What do you have? Differentiate 2x. What will you have? This one is the simplest too. Differentiate 2x. What do you have? Tina, yeah, thank you. So that is plus 2. Yeah, good. Then when you differentiate, you know this one. When you differentiate 3 is what? A constant. When you differentiate a constant is what? When you differentiate a constant is not 3. When you differentiate pentagon, kitchen pair, it's not 3. It's not x. So when you differentiate 3 is what? A constant is 0 now. I told you when you differentiate a constant is 0. It is 0. Whenever you differentiate a constant, it is 0. Please don't forget. So now, after you differentiate the second time, step 4 now says substitute the value of this x inside this guy. That is step 4. Substitute the value of x inside this guy. You now say at x equals to 1. Let's try for 1 first. Are you seeing it now? I'll put at x equals to 1. Are you seeing it? Yes. So at x equals to 1, let's put it inside here. That will be d square y over dx square equals to 2. Anywhere I see x, I will put what? 1. That will be 2 times 1 plus 2. What is 2 times 1? That will be 2 plus 2 equals to 4. Now, is it greater than 0 or less than 0? Is it greater than 0 or less than 0? Look at this guy. Is it greater than 0 or less than 0? Is it greater than 0 or less than 0? It's greater. And when it is greater than 0, what do I call it? When it is greater than 0, what do I call it? That is our what? When it is greater than 0, what do I call it? When it is greater than 0, what do I call it? Why are you laughing? Who is laughing? That's our minimum. You see that this is how you get minimum point. Sharp. This is how you get minimum point. So you try again for the next one. At x equals to, what's the next x? It's not maximum, Amira. It's minimum. When it is greater than 0, it's minimum. So at x equals to minus 3, put it inside here again. What is the square y over dx square? The square y over dx square will give us what? 2x plus, okay, that will be, at x equals to 3, that will be 2x. So what's our x? Minus 3 plus 2. So that 2 times minus 3 is minus 6 plus 2. Minus 6 plus 2 will give us what? Yeah, minus 6 plus 2 will give us what? Minus 6 plus 2 will give us what? Minus 4. Thank you. And when it is less, is it greater than 0 or less than 0? Oh yeah, tell me. Is it greater than 0 or less than 0? Is it greater than or less than 0? Where did 3 come from? This is it now. We've put for x equals to 1 and we have put for x equals to minus 3. So it is less than 0. And when it is less than 0, what do we call it? That is when it is maximum point. That is when it is maximum point. So that is how you get your maximum and minimum point. That is how you understand. That is how you get maximum and minimum point. That is just how you get maximum and minimum point. Are we all clear? Are we all clear? Oh, okay, yes. That is just how you get it. So that is just how you get maximum and minimum point. I love this, yeah. Have you written the formula before? Yes, I wrote the formula before. It's not formula, it's just steps. It's just steps. It's not formula, it's just steps. It's just steps, it's not formula. It is only steps, not formula. Yes. So that is just how you get maximum and minimum points. So in the exam, whenever you see questions like this, you don't need to cram. You don't need to, good evening. How about stationary point? No, stationary is when you have equals to 0. There's no need for getting that one. You know, stationary is when you have equals to 0. So, but we don't have equals to 0 there. You know, if your d square y over dx square gives you 0, this is your second derivative. Can I please write the formula again? And I did not snap it too. Oh, I didn't think I knew I would have written it somewhere. I didn't snap it. But don't worry, don't worry. Don't worry, I will show you where you get it. Do I have video on it? I'll show you where you get it, don't worry. I'm not sure I have videos. Did I do stationary on? I doubt it. I doubt it. Don't worry, I'll show you, don't worry. Don't worry, I will write it, don't worry. Just remind me before I end the class, I will write it. Please, let's continue, we'll do that later. Alright. So that's how you get stationary and minimum. Who is laughing? Who is that one laughing? So now, let's try and get, if they ask you maximum and minimum value. Now listen. Oh. Let's say they ask you, I told you there's difference between maximum and minimum point, right? There's difference between maximum and minimum point and maximum and minimum value, right? Do you get it? You know, I told you now that there's difference between maximum and minimum. Yes. Which one is game over? Right? You know, I told you there is difference between maximum. So now let's say they ask you for maximum value and minimum value instead of maximum point and minimum value. You see where you have gotten to this place, because after you have gotten to this place, you see this same at x equals to 1 and x equals to minus 3. So instead of putting it inside the second derivative, you know, is the second derivative we use to get the point. But if it is value now, we will not put it inside the second derivative. We will come back and put it what? We will come back and put it inside the curve. This is the curve. You see that they say the curve whose equation is, this is the curve equation. Sorry, we'll soon finish now. This is the curve equation. So if it is maximum and minimum value, you will now come back here and put it. You now say at x equals to 1. So instead of putting inside the second derivative, we'll put it here. Do you get it now? That will be y equals to, what will be your y? That will be, our x is 1. That is 1 cube over 3 plus 1 square minus 3 times 1 plus 4. You are not late. Not in the second derivative, but yes. So 1 cube will give us 1 over 3 plus 1 square will give us 1. Then minus 3 times 1 is 3 plus 4. So what are we going to have? 1 over 3 plus 1 minus 3 plus 4. What are we going to have? 1 minus 3 is what? 1 minus 3 will give us what? Minus 2. Minus 2 plus 4 will give us what? That will be 1 over 3 plus 2. 1 minus 3, you didn't even know I was there, sorry. 1 minus 3 is minus 2. Minus 2 plus 4 will give us what? Plus 2. So when you do the LCM here, so this will give us what? This is over 1. The LCM is 3. 3 in 3 is 1. 1 times 1 is 1. Then 1 in 3. 3 times 3 is what? 6. So that gives us 7 over 3. And that's how you get it. So that's how you get it. Or better still, you can do the LCM for everything. That will be 1 plus 3 minus 3. You get 1. You can do the LCM for everything. So that is just what you are going to have. So if you check it now, are we correct with it? Or should we do the LCM for everything? Let's do the LCM for everything. So 3 in 3 is 1. 1 times 1 is 1 plus 3 minus 9 plus 12. 1 plus 3 is 4. 4 minus 9 is what? Oh, it's wrong. 4 minus 9. 4 minus 9 will give us, okay. 4 minus 9 will give us minus 5 here. 4 minus 9 is minus 5. Then minus 5 plus 12 will give us 7. So that is 7 over 3. So this will be our what? So you see that it is greater than what? It is greater than 0. So this is called the minimum. So this is called the minimum value. So this one is called the minimum value. So that is called the minimum value. So it is called the minimum value. I checked you on Twitter, I didn't see you there. I said, let me check here, I found you. Oh, welcome me. Minimum, yeah, that's the minimum value. You see that it is greater than 0, right? So that's your minimum value. They can't ask you minimum value in the exam, I doubt it. They can't go beyond minimum points. Will you post the video? I don't have video on it though. That's the funniest part. I don't have video on it. That's the funniest part. So that is just how you get the minimum value. The minimum value. So for maximum value, you put the same thing. At x equals to minus 3, you put it inside here. That's how you get the maximum value. So that is how you get the maximum value. Are we all clear like that? So I'll come again in the last part. Okay, let me come again. This is it. For For minimum, let's say, you know, there's difference between maximum points and maximum and minimum points, and maximum and minimum value. But in the exam for Jambite, they will stop here. Either they ask you for maximum and minimum points, that's where they will stop. They can't ask you for value. But I'm just doing it just in case, you know, now, just in case they decide to what? Just in case they decide to ask. So I know they can't ask, but just in case they decide to ask. So how do you get minimum value and maximum value? Instead of putting it inside the second derivative to get your points, you won't put it there. You know, these are the values of x. These are the values of x. So you won't put it there. So can't you divide through by 3? No, divide through by 3 as well. You can't divide through by 3. Oh. It's not possible here. Here is LCM now. It's not, here is LCM. You have to do the LCM. So this is how you do it. You have something like this. Me, I did shortcut. I said 1 minus 3 is what? 1 minus 3 is minus 2. Minus 2 plus 4 will give me what? Will give me plus 2. That's why I wrote 1 over 3 plus 2. Or if you don't want to do it like that, I don't know. If you don't want to do it like that, what is the LCM of everything? The LCM of everything is what? The LCM of everything is 3. You do LCM of everything, 3. Now, 3 in 3 is what? 3 in 3 is 1. 1 times 1 will give us 1. Sure you get? So, 1 times 1 will give us 1. Then plus, this is over 1. Over 1. Now, 1 in 3 is 3. 3 times this one will give me 3. Then this is also over 1. 1 in 3. So 1 in 3 is what? 3. 3 times this 3 here will give me what? Minus 9. Then this is also over 1. 1 in 3 is 3. 3 times 4 will give me plus 12. 1 plus 3 is 4. So 1 plus 3 is 4. 4 minus 9. 4 minus 9 will give you what? 4 minus 9 will give you minus 5. Minus 5 plus 12 will give you 7. So that will give you 7 over 3. So if you check the answer, 7 divided by 3 is what? Is 2 point something. It is still greater than 0. That is our minimum value. So if you want to get maximum value now, you put your x minus 3 inside the same equation. And that's how you get the maximum value. Do you get it now? So that is just how you get maximum value. So it's as simple. But for Jambite, they can't ask you to this point of maximum value. Where they can stop is minimum and maximum points. Or the formula. You know, I told you there's a way they can ask you question in the formula. So 1 over 3. You put x equals to 1 inside the same curve. It will be inside the question back. You will return inside the question. So anywhere I see x, I'll put what? 1. This will now be 1 cube over 3 plus 1 square minus 3 times 1 plus 4. That is what you're having. 1 cube. Anywhere I see x, I'll put 1. Sure you get. That will be 1 cube is 1. 1 cube is 1 over 3. Then plus 1 square is still 1. Then minus 3 times 1 is 3. Then plus 4. So that is just that about that. Are we all clear now? Are we all good to go? Are we all good to go? Are we all clear? Okay, yes. So you can try for maximum value yourself. Just put x equals to minus 3 inside this curve. You can try that one later. You get your maximum value. So that is all about maximum and minimum point. It's part of JAMB syllabus. But you see that if they did not ask you question, where me I know they can ask you question is from that formula. Take note and listen now. If they did not ask you questions like this, you know I tell you that they can ask you that if the square y over the x square is less than 0, if it is less than 0, what point is it? Is it maximum or minimum or stationary? If it is less than 0. Alright. The answer is minus 5, no problem. If it is less than 0, is it maximum or minimum or stationary point? You see that I'm asking you now because it is what? If it is less than 0, that is maximum. So you see that if they did not ask you questions like this in the exam, they can ask you from that formula. Don't forget, when your d square y, I just have to keep writing it. When you square y over the x square, when it is less than 0, that is called the maximum point. But if it's your d square y over the x square, if it is greater than 0, that is called the minimum point. But if it is equal to 0, that is called the stationary point. That is called stationary point. So please don't forget to. Alright, so screenshot and let's solve. Let's go to another. I think I will just even end it here, set on differentiation. Let me end it here instead of giving you another thing. Let me end it here and go into integration. Let me end it here and go into integration. So please screenshot, then let's go into integration. Let me leave the rest. Because if I say I should confuse you now, look as if. Alright, everyone, welcome. So please screenshot. Can I clean? Can I clean? Can I clean? Can I clean? Alright. Are you sure I can clean? Which one is dy dx? Which one is dy dx as well? Yes, yes. Yes, clean. What was the question already at? Which one is dy dx? dy dx is your first derivative. Is your first derivative. Yes, let's go to integration. Let's go to integration. Don't let me disturb you. Integration, I'll teach you the basic of integration. I'll not go deep. I'll just teach you the basic. I'll teach you the basic and we finish. So, if you can finish it tonight, tomorrow we'll go into trigonometry. So tomorrow will be for trigonometry. If you can finish it tonight, tomorrow will be for trigonometry. So please make sure you invite people tomorrow. Invite people tomorrow. So let's go to integration. Alright, integration now. Integration. So I'll just teach you the basics. I won't go deep inside this guy because all these things does not really matter like that. So I won't go deep. Yeah. Which one? I don't understand. Which one is now dy dx? Which one now? I was asking you which dy dx. I said dy dx is the first derivative. So is it here you want to be going live now? Right there, yes. I said those three big topics: differentiation, integration, and trigonometry. I didn't mean I'm doing it on TikTok now. I would have, I will spend like 1 week and finish it. 1 week or 2 weeks. Because they will be asking me, I don't understand. Now, yeah, I only have 31 people and it's better. I have 32 people. It's better because if you are following me and you join early and network is not disturbing you, I can easily attend to your question. Even your question will be limited itself because if you start with us, you will actually get it if you are not being distracted. If you are not being distracted, you will get it. And if your network does not frustrate you, you will get it because the way I'm doing it is step by step. So now assuming I'm doing it on, I have more views on TikTok now, but you know how many questions I would have answered on TikTok. It's better I come here, don't worry. Let's just manage this place like this. So products one change. Don't worry, wait, I'll tell you where you watch it. Just wait. So let's go to integration. We'll finish integration tomorrow then. Today, we finish integration today and tomorrow is trigonometry. So invite people. But before I give you, good evening, Amarachi. But before we solve examples, let me give you the tables. Just in case they ask you tables, just in case. I will not give you much, don't worry. I will not give you much. I'll just give you short tables. Short tables. So please make sure you're write with me then. Under integration, there are two types of integration. Under integration, there are two types of integration. Maybe I should write it here. There are two types. We have the indefinite integral, and we have the definite integral. So I won't bombard you here, but before we solve examples, let me give you some formulas. Alright, so please follow me as we go together. So under integration, I'm not rushing you, so make sure you follow me. I'm not going to rush. So under integration, there we have just two types of integration. We have the indefinite integral and the definite integration. Now let me break it down for you. You know I'm not reading comment though, so make sure you are listening. Just listen. Oh, I have to be reading comment again. Okay, alright, good to go. Alright, so please listen. So under integration we have indefinite integral and definite. Now which one is indefinite integral and which one is definite integral? Now listen. Indefinite integral, you see this indefinite integral are the ones without boundary. You know this is the sign for integration. You know anytime you see this sign, this is the sign for integration. So when you have an integral sign like this and there is nothing here, you don't put anything. This is called an indefinite integral. It is called what? An indefinite integral. But when you have something and they put something here, A and B, let's say they put a limit, this is now called a definite integral. Take note of these two things. You know I'm not rushing now, but please make sure you are not distracted. Make sure you are not distracted. I'm not rushing. Around integration now, which one is pushing through? You're on integration already now, so leave that one. So alright, so these are the two types of integral now. Hope you can differentiate between indefinite and definite now. Alright, can we all differentiate between indefinite and definite now? Can we all differentiate between child? What is child? Can we all differentiate? No. Look at it now. Why are you doing it intentionally now? I've not even solved anything. Look at what is on the board. You are still saying no. Alright. So this is indefinite. Indefinite integral is when there is nothing here. When it doesn't have a boundary. That is indefinite integral. Alright. So what definite integral is when it has a boundary. So whenever you see an integration like this that doesn't have anything here, this is an indefinite integral. But whenever you see something like this, they say 0 to 1. You see something like 0 to 1, that is a definite integral. Do you get it now? But let me teach you something now. We'll do for both and we'll call it a day. We'll do for the two and we'll call it a day. Sure you get. But make sure you listen very well. So we'll do for both. So but under indefinite integral, alright, no problem. Under indefinite integral, whenever you solve an indefinite integral, you add plus c to your final answer. But whenever you solve a definite integral, you don't add plus c. Those are the two things. Take note now. We will solve questions. Don't worry. Under indefinite, whenever you integrate a indefinite integral that doesn't have boundary, you add plus c. But when it has a limit, you know when they put limit now, it means it has a limit to which it can go. Do you get? It means it has a limit. It can't go beyond this limit. So, but you don't add plus c to your final answer. Now let's go. That one does not really concern you, but let's go. Let's solve questions now. Now, before we solve questions, let me give you some formulas. Let me give you, yes, a constant, yes. Let me give you some formulas, then we solve questions. Just under these guys and we'll finish. Now, the formulas are called standard integral form. The formulas are called standard integral form. So let me give you those formulas. Sorry. Yeah, plus c for indefinite, yes. Good evening, welcome in. Welcome. Now, these are the formula. Now, let's say you're giving integral of dy dx and you are getting y. These are the formulas I want to give you. The first thing I will give you is the formula. What of definite? You don't add plus c. Definite, you don't add plus c to your formula, to your answer. You don't add plus c. Now look at it now. The first thing I will give you is the formula. Whenever you are told to integrate x to the power of n, look at integration now. You know, we've done for differentiation. Now look at integration. How do you integrate in the exam? Sorry. How do you integrate in the exam? If you wait, I will tell you where you watch it. Just wait. If you wait, I will tell you where you watch it. Wait till the end of the live, I will tell you. We'll also finish this guy now. So this is the formula. Whenever you are told to integrate this guy in respect to x, they will put what you are integrating in respect to. Now, it is simply what? Integration is just all about add 1 to that power. Just add 1 to the power over that same power. Then you add plus c. You see that the reason why I'm adding plus c is because it doesn't have boundary. These are standard indefinite integral. They are called standard, let me write it again, standard indefinite integral. Standard indefinite integrals. So these ones are called standard indefinite integral. So look at it now. Integration is all about you add 1 to that power over the power. Simple. How many of you understand what I do? Understood? Thank you. By Emmanuel. Let me give you one example. Let's say they say integrate x cube in respect to dx. Now look at it. The dx we are seeing here means I'm integrating in respect to x. The dx we are seeing means I'm integrating in respect to x. Now, what do I just say you do? You add 1 to that power. What is the power here? What is the power here? What is the power? Yeah, everyone, thank you. What is the power? Oh, yeah, tell me now. You to talk now. You see that the way I'm taking it slowly is because we are not much. I think Bin is on TikTok now for those the shout. 3. So you add 1 to that power over that same power. What is the power? 3 plus 1. What will be your answer? X to the power of 4 over 4. Do you see it now? Do you see it now? Do we understand? Then you add plus c. Thank you. You add plus c because it is what? Indefinite integral. You can tell me now if you understand. Make I know now. Add plus c. Yes. What of plus c? I know. I've added it. Sure, you get it now. It's only plus c when I remember. Plus is that plus c when I when waiting they ask me to integrate them. You people not tell me that you people are funny. It is that plus c going you people understand. So alright. So you're laughing. It's true now. When I say is it correct, you did not even first confirm is the plus c you people are after. You are after plus c. Alright, so let me give you another example. Let's say it's ordinary x. Integrate x in respect to dx. Integrate x in respect to dx. What would be the answer? If you like, you know add your own plus c join your answer now. You see the way I'll shout at you. You don't add plus c to your answer. Oh yeah, integrate ordinary x. What would be the answer? X square over 2 plus. In row word is a bit book. No, cannot check in row word. The front. Chinfon too got it. The front child, you did not complete it though. Oh yeah now. Rodia is not 1 now. Where is 1? Where is your 1 coming from? Akimpowale is not 2. Look at it now. What is the power on the x here? The power on the x here is what? What is the power on the x? Friday is not x, so listen. The power on the x is what? Rodiat. The power on the x is what? What is the power on the x? 1, right? So that would be x to the power of, add 1 to that power over that same power. So that will give you x squared over 2 plus c. And that is all. Short, which one is x over x? That's x squared 1 plus 1 over 1 plus 1. Add 1 to the power over the power. It is not add now. So let's continue. That is just the first thing. That's the formula. We'll come back to it again. Now, the next thing you need to know is Whenever you integrate a constant in respect to dx, whenever you integrate a constant, you don't do differentiation. In the exam, if they give you differentiation, don't go and do integration. If they give you integration, don't go and do differentiation. It's better you so you don't vex. So I no vex now. People don't type answer, no vex. And they had me type for it. I'm not angry now. So whenever you integrate a constant, I'm not angry. Whenever you integrate a constant, you have, differentiation is different, but integration, whenever you integrate a constant, you have that constant with x. That is all. Now, let me give you an example. Yes. Whenever you integrate a constant, you have that constant with x. Let me give you for example. For example, let's say we are told to integrate ordinary 5 in respect to dx. You see, listen to this part very well. If they say integrate ordinary 5 in respect to what? Dx. The dx you are seeing here, it means I'm integrating in respect to x. That's the meaning of that dx you are seeing. So it means anything apart from x is a constant. Are you getting me now? So it means anything apart from x is a constant. Now, is there x there? Check. Do they give me x? Check. Is there x there? Is there x? Check. Is there x there? Skip. Sorry, I did not skip now. Am I skipping? No, there is no x. So it means that I can say my x is to the power of 0 in respect to dx. I can say the power of my x here is 0. Right? X to the power of 0 will be 1. 1 times 5 will go back to 5. Right? I can write it like this now. Since there is no x, I can say the power of my x is 0. I don't understand this thing now. Prince. This thing now. There is no x. If you have 5x, it's different from when you have 5. If you have integral 5x, what is the power of your x here? If you have integral 5x, what is the power of your x here? No. If you have integral 5x, what is the power of your x here? 1, Abi. What do you know this thing? Let them know it. Let them talk to me. 1. That's 1, right? Now, if you have ordinary 5, who can tell me? There is no x here, but who can tell me the power of my x here? Ordinary 5 now, but I want to do it in respect to x. I want to put it in respect to x. Who cannot tell me the power of my x here? It can still be the same thing as x to the power of 0. X to the power of 0 is 1. 1 times 5 is still 5. It will still be that 5. But since I'm doing it in respect to x, I just need the x there. But what will not be the power of the x? It is 0, not 1. Do you understand it now? Do you get it now? So I'm just trying to explain. Normally, I can just tell you that integration of a constant is that constant is x, just like what I said here. But I'm trying to prove it for you so that you can know how it becomes what? How it becomes that constant with x. So it means that when I integrate 5 now, I can change it. Since I'm doing it in respect to x, it means I can say my x here is power of 0. Now, what do we do? When you want to integrate, that will be x to the power of, what do we used to say? If you want to integrate, you add 1 to that power. What is the power? 0. Add 1 to it over 0 plus 1 over that same power. Do you get it now? So that will give us 5x to the power of 0 plus 1 is 1 over 0 plus 1 is 1. That will give me 5x. You see that? That will give me 5x plus c. Before they will say I don't put plus c now. Do you get it now that when you integrate a constant, you have that constant with x? Do you get it now? You don't understand. Do you understand it now? I know. Do we understand it now? Yes. You did not put it before. I know. Which one did I not put before? Do you understand? Alright. So, you see that when you integrate a constant, it is that constant with x. Don't stress yourself. I'm telling you now, so that you will save time in the exam. So that you will save time to yourself in the exam. Whenever we integrate a constant, you have that constant. Who told you know what is a finalist? You have that constant with x. But when you differentiate a constant now, if you differentiate a constant, what do you have? You should know this one by now. All these things, put it by heart. Forget someone break your heart. Forget those stories. Put it by heart now. There are some things that you don't need to solve. You just need to know it by heart. Know it offhand. Shey you get. But if you differentiate a constant now, what do you have? If I say differentiate a constant, differentiate 5, what do you have? It's true now. Differentiate 5. It's true now. The way you people are, something that I'm not supposed to be proving, doing stress thing. I'm just telling you, put it in the head. It's simple English. Differentiate a constant now, you have what? You see some people say x squared. It's not x squared. Differentiate it. Who is laughing there? Who is that one? Differentiate a constant is 0. Differentiation of a constant, if I say differentiate 5, it is 0. But if I say integrate 5, what will you have? If I say differentiate 5 is 0, but if I say integrate 5, what do you have? Integrate 5, what do you have? It's not 5. One burning. It's not 5, one burning. Friday, different. Integrate 5, it is 5x now. Even if you don't add plus c first tell me the correct answer first. Some people here have chop hard break. Book is now stressing himself to enter. Some people here have chop hard break. That's what is disturbing them. Since morning, I still did this thing since morning. Something where I think I will not finish. I'm getting sir, you don't need vex for us. Now. I'm not angry now. But the way this thing is supposed to be entering your head straight. For most of you, it is that guy that says no more pain that is in your head. Something that is differentiate. I say if you differentiate a constant, it is 0. But if you integrate a constant, you have that constant with x. Simple. Put it in the head. If you differentiate a constant, it is 0. But if you integrate a constant, you have that constant with x. Kill me. It's not complicated now. Is it not English? It's not complicated. It's not English. Richie, welcome in. It's English now. I've tried giving you the formula. You see that in the exam, it's not everything you solve. There are things that just the formula will help you. That's what I'm giving you. Just the formula will help you. That's what I'm giving you. Alright, the next one, when you integrate, when they ask you the integration of sin x, in respect to dx, it is minus cos x plus c. Now let me just give you the rest. Don't worry. If you like, try and read. By trying it will help you in the exam. Then sin x plus c. Then sin x. Alright. Then number 5. If they give you sec square x in respect to dx, you get tan x plus c. Number 6. If they give you sec x tan x, integral of sec x tan x in respect to dx, you get sec x plus c. Number 7. If they give you integral of cosec square x in respect to dx, you get minus cos x plus c. What the heck? I don't know. Alright, let me just give you this formula, then try and rate. Then when you have cosec x cot x, cosec x cot x, you have minus cosec x plus c. Minus cosec x plus c. So let me just give you the major ones you will need in the exam. The major ones you are going to need. dy dx. Then we have y. So let's say number 9. Let's say you were told to look for integral of exponential x in respect to dx. It is still the same exponential x plus c. Now let's go for 10. Integral of exponential kx dx. It will give you exponential kx over k plus c. This man the Yankee. If you know Yankee, number 11. It is integral exponential minus kx in respect to dx to give you exponential minus kx over minus k plus c. So then the 12th one, if you have integral sine kx in respect to dx, integral sine kx in respect to dx, integral sine kx in respect to x, it is minus cos kx over k plus c. Then 13, if you have integral cos kx in respect to dx, it is sine kx over k plus c. So I won't give you more than that. Then 14, if you have integral 1 over square root of 1 minus x squared in respect to dx, it is sine inverse of x plus c. Then 15, if you have integral 1 over 1 plus x squared, 1 over 1 plus x squared in respect to dx, it is tan inverse of x plus c. Then 16, if you have integral of 1 over x, it is called mean x plus c. So that is where I will stop on my preferred TikTok live to YouTube. As now, are we not comfortable here? You should be comfortable here now. You see that here you can ask me question. It's not like the question would have moved fast before I see it. I have to put all these things for here though. You have to put it though, because majority, most of it might not be solving. I told you, majority, most of it might not be solve. Most of it might be just using the formula. So that is just that about that. So all this formula done with me. Alright, so this is it. So in case if you can try and put some here, please try. But I will not be explaining it so that it will not start giving us problem. Let's just go and solve questions. So but if you can try and put it in your head, please try and put. How we go? Put this for head now. You go put an on you. Me too, I wrote it off and now. You see the way me too I wrote it from my head. So don't let me explain anything. Let me just leave it like that. Let's go and solve questions. For the next 30 minutes, we'll just solve two questions or so. Then we'll go to the next thing. Two questions or so, then we'll go to the next thing. Oh yeah, are we ready? So I'll be prof now. As long as you said my senior prof now. You two are senior prof, or there's no prof, nobody is called prof. You two are senior prof. Let's go. Action speak louder. Oh yeah now. It is not clear. What's not clear? If you just memorize the rule you gave us yesterday, it go easy. Yeah. Emmanuel. So if you remember differentiation, right? Integration will not be hard for you. So if you remember integration, okay, let me just try and explain some to you. You know when you differentiate an x, if you differentiate an x in differentiation, you have set square x. You see that same thing, if you now integrate that set square x, you go back to tan x. You don't get what I'm saying. If you differentiate sec x in that differentiation, if you differentiate sec x, you get sec x tan x. But if you now integrate that sec x tan x back, you go back to sec x. If you differentiate cot x, you have minus cos square x. It means if I now integrate that cos square x back, I have minus cot x. See that these are very simple. But when it comes to exponential x, if you integrate exponential x, it's still exponential x. If you integrate exponential x, you still get the same exponential x. If you differentiate exponential x, you still have the same exponential x. But if you now integrate exponential kx, you know for differentiation, we said the k come outside, then raise to power that kx again. But for integration, it will now be exponential kx over k. It comes as division. You know for differentiation, it will come as multiply. It will come down and multiply. But for integration, it comes as division. So meaning if they say integrate exponential 2x, integrate exponential 2x, what will it be? It will be exponential 2x over 2. Sharp. Shall you see it now? That's integration. You know it will be exponential 2x over 2. Right? Shall you get it now? So if you see that if they now say integrate exponential minus 2x, if it is minus 2x, then it will now be exponential minus 2x over minus 2. That is for this one. It's very simple. For integration, it comes as division, but for differentiation, it comes as multiply. So the same thing here. You know when you use sin kx, we say k will come outside, then differentiate sign is cos abi. That would have be k cos kx. But for integration, integrate sin kx. You know when you integrate sign is minus cos. That's minus cos kx. That k now comes as division. It's very simple now. This thing is just logic. Very simple. So you see that when you differentiate sine inverse of x, we have 1 over root 1 minus x squared. If you now integrate that 1 over root 1 minus x squared, you have sine inverse of x. You see that when you differentiate tan inverse of x, you have 1 over 1 plus x squared. So when I integrate that 1 over 1 plus x squared back, I have tan inverse of x. So in the differentiation, when you differentiate ln x, you have 1 over x. If you differentiate ln x, we have 1 over x. But when you now integrate that 1 over x back, you go back to ln x. But we are adding plus c to everything because it is what? Indefinite integrals. Because it is blue. We can't see that. Sorry. Yeah, my God. It is very blue. Sorry, wait, hold on. Where's my handkerchief? How about now? How about now? Blushy. It's clean, alright, it's better now. Sorry. I did not know. So I was just talking to myself all this while. Azam now. So since morning I was just talking to myself. Or do you guys hear what I was saying? Do you guys hear what I was saying? Alright. So please screenshot and let's solve examples. It's better, alright. You thought error word has gone. Error word is always here to be finished. Alright, screenshot and let's solve examples. So in case if you can put it in your head, fine, it's a bonus for you. But let's go and solve questions where they can ask you questions. Let's go and solve questions. Can I clean now? Can I clean? Thank you, everyone. Let's see in the next 30 minutes or so we round up. In the next 30 minutes. It blow. It's not blow now. It's not blow. Oh. Blushy. Which one is blushy? Is it okay now? It's better now, right? Alright. Can I clean now? Can I clean? Let's solve questions. Can I clean? Can I clean it now? Yes, we had. So can I clean now? Alright, so let me clean. I will solve questions. Can you show me what I'm feeling? Can you show me how I'm Can you show me Now, indefinite integral. Indefinite integral. Now on this guy. So let's solve examples. Then we'll go to definite. So the question says, find the integral. Find the integral of the following. Find the integral of the following functions. Find the integral of the following functions. Question 1. Integral 4x in respect to dx. Question 2. Integral 3x squared plus 2x minus 5 in respect to dx. Question 3. Integral 3 exponential x in respect to dx. Question 4. Integral square root of x in respect to dx. Then question 5. Integral x plus 1 over x in respect to dx. Then question 6. Integral x cubed minus 3x squared plus 2x plus 5 over x, all in respect to dx. Solution. Now let's solve these questions together. Okay, what did I miss? Alright. Are we ready? Are we ready? Are we ready? Are we ready? Yes, alright. So let's do this once and we'll call it a day. Let's do this once and we'll go to definite. We'll just solve 2 questions in definite and we'll call it a day. Alright, so it's only Tina that is ready. Since it's only Tina, then let me teach only Tina. Alright. So I solved question 1, you solve question 2, I solved question 3, you solve question 4. Alright. Then we'll solve it like that and I'll give you the rest as assignment. Now, are we ready? Question 1. Samuel friends, welcome. So question 1 says integral of 4x in respect to dx. Now, look at this guy. When you have integral of 4x in respect to dx, the dx means I'm integrating in respect to what? What does this dx mean? It means I'm integrating in respect to what? Oh yeah. The dx means I'm integrating in respect to what? X, right? Thank you. So it's only Tina that is here. Okay, I think Baba is still here. Alright. So it means what will happen? I can bring my 4 out. It means the 4 can come outside. Then I will have integral x inside in respect to dx. Shall you get? It means the 4 will come outside. It means anything that is not x is a constant. You bring it outside. Do you get? So 4 will come outside, then x. So 4 times x will still go back to 4x. But since I'm integrating in respect to x, it means anything apart from x is a constant. So what do we now have? What are we going to have? We are going to have 4. When I want to start integrating, I don't use the sign again. I use the bracket sign. What is the power on the x? The power on the x is what? What's the power on the x? What's the power on the x? The power on the x is what? 1, right? T9, which one is 4 plus 1? It's not 4 plus 1. Calm down. The power on the x is what? 1. So what do? You add 1 to that power over that same power over 1 plus 1. So what are we going to have? We are going to have 4x squared over 2. T9, it's better you calm down. So 2 here 1, 2 in 4 will give us what? 2 in 4 will give us 2x squared plus c, and that's the final answer. And that's the final answer. Do we all get this one? Do we all get this one? Do we all get it? Sense, yes, alright. So we all got this one, right? Alright. So let me go for number 2. Let me go for number 2, then I'll give you number 3 to solve. For number 2, yeah, 2x squared plus c, yes. For number 2, I have integral of 3x squared plus 2x minus 5 in respect to dx. What does this guy mean? If you have something like this, it means you will integrate them separately. That is the meaning. It means you will do what? You will integrate them separately. So let's integrate, you integrate 3x squared separately in respect to dx. You will integrate, the next sign is plus. I will integrate the next thing, 2x in respect to dx. Then the next sign is minus. I will integrate 5 in respect to dx. Now, do we understand this part first? Confirm first, confirm. Do we understand? Yes, do we understand this part first? Do we understand? Okay, yes. I want you to follow. Okay, write down. I like all of you. Write down. Integration is simple. Okay. So now, it means the dx means I'm integrating in respect to x. It means 3 will come outside here. 3 will come outside. I'll be left with x squared dx. It means 2 will come outside. I'll be left with x dx. Then here it means, you know that when you integrate 5, oh yeah, if you do not get this one, I will pursue you outside here. If you do not get it, I will send you outside. If you integrate 5, what is your answer? If you integrate 5, what is your answer? If you integrate 5, what is your answer? Thank you, favor. So you people sabi book like this. Why can't they teach this thing when you people understand it? It's not 1 or money. If you integrate 5, it is 5x when you don't understand English. I say when you integrate a constant, you have that constant with x. So, but you already know it will be 5x, but let's just do it mathematically. That will be x to the power of 0 dx. Let's just do it mathematically. So here will now be 3 into brackets x to the power of, what is the power on this x here? Yes. What is the power on this x here? The power on this x is what? What is the power on this x? 2. So what do? You add 1 to it. 2 plus 1 over that same 2 plus 1. Then plus 2, here will be 1 plus 1 over 1 plus 1. Then here will be minus 5. Here will be x to the power of 0 plus 1 over 0 plus 1. Alright. So what will be our final answer here? So here will be what? Come on, this thing is 0. So here will be 3x cubed. Here is 3x to the power of 3 over 3, right? Then plus here is 2x squared. 2x squared over 2. Then here is minus 5x to the power of 1 over 1. So here will be x cubed plus x squared minus 5x plus c, and that's the final answer. And that's the final answer. You know, 3 cancel 3, 2 cancel 2. So that will be x cubed plus x squared minus 5x plus c. Do we get that one? Yes. Yes, favor. Yes. Do we get it? Are we okay? Alright, so since we are all clear, alright, let me go to question 3, then I'll go to question I'll go to question 4 and I'll give you question 5 and 6 as assignments. So let me just solve question 3 and 4. Gotcha. Alright. Question 3 is very simple. Question 3, what is the answer? Who can tell me? I have 3 exponential x dx. Who can tell me the answer before I write it? If you tell me the answer, you dash 1 marker. Favor, so you sabi book like this. Come dey stress me. What's the answer for question 3? It's only favor I see. Oh. It's only one answer I've seen. Yeah, now. Easy now. I know easy. Tell me the answer now. What's the answer? Oh yeah, let me solve it. Since you people are not typing the answer, let me solve it. So the answer will be what? Alright. Yeah. So the answer will be 3 will come outside. Then integrate exponential x dx. Then when we integrate exponential x, I told you it's the same answer, right? So that will be 3 exponential x. That will be 3. When you integrate this guy, it's still the same thing. Then plus c. And that's the final answer. Okay, yeah, I know. Don't worry. So let me solve question 4 and I'll give you 5 and 6 as assignment. Question 4. So for question 4, I have integral square root of x dx. Now in the exam, look at it. When you have something like this, you have to first write it. Another way of writing square root of x is what? Another way of writing anything square root is what? Another way of writing it is x to the power of 1 over 2, right? Is that not it? I bet gaming rank, you better you leave here. Which one is Rolodo? You know, say those who follow me on YouTube, now themselves won't sabi book. You don't know anything. You know, say those who follow me on YouTube. It is here I do this one for TikTok. No, you think it's easy. You know how much data they are burning here. You say now them they play. So it means that we have to first write square root of x as what? X to the power of what? 1 over 2. So it means now what do we do? It's very simple now. So what do? Just add 1 to the power. That will be x to the power of 1 over 2 plus 1 over 1 over 2 plus 1. Do you get? So what will you do? You do LCM. For 1 over 2 plus 1, you do the LCM. This is over 1. The LCM is 2. Right? It's okay. 2 into is what? 1. 1 times 1 is 1. Then plus 1 into is 2. 2 times 1 is 2. 1 plus 2 gives us 3 over 2. So it means here will now be x to the power of 3 over 2 over 3 over 2. That will be x to the power of 3 over 2. Alright. So that will be x to the power. You know, when you change it to from square root of x, you change it to x to the power of 1 over 2. That's another way of writing square root is 1 over 2. So what do you just do? When you want to integrate, just add 1 to the power plus 1 over that same power. So when you do the LCM is 2. 2 into is 1. 1 times 1 is 1. Then plus 1 into is 2. 2 times 1 is 2. 1 plus 2 gives us 3 over 2. So that's x to the power of 3 over 2 over 3 over 2. But to finish it, if you want to finish it, you know, 2 can go up and 3 will be down. So that will be 2 over 3. Then that will be square root of x cubed. I know some people will not understand this one. Can you even see that part? Can you see that part? That will be 2 over 3. Let me explain. I will explain it. Then square root of x cubed plus c. And that's the final answer. But let me explain it. Because I know some people will be surprised. Let me explain it. Now, how do you... Okay, you understand. Okay, but let me explain it. You know you have x to the power of 3 over 2 x to the power of 3 over 2 over 3 over 2. X to the power of 3 over 2 over 3 over 2. You know, it's just like saying x to the power of 3 over 2 divided by 3 over 2. You know, that's the same thing. It's just like saying divided by 3 over 2. I'm explaining already, just listen. You know, it's just like saying x to the power of 3 over 2 divided, this is divided by 3 over 2. Yeah. So what will it now be? That will be x to the power of 3 over 2. When you change division to multiplication, what happens? 2 goes up, 3 comes down, right? 2 goes up, 3 comes down, right? Are you following? 2 goes up, 3 comes down. So that becomes 2 over 3. Then this x to the power of 3 over 2 means 3 times 1 over 2. Is that not the same thing? Yes. So you see that this 3 over 2 is the same thing as 3 times 1 over 2. So when x is raised to the power of 1 over 2, what do we used to call it? When it's raised to the power of 1 over 2, you know we used to say square root of x, abi? So that will be 2 over 3 square root of x. Then what is in here? Cube. And that's how you get it. Then you add plus c to your final answer. Are you clear now? Are you clear? Yeah, yes. That's, you know, when you have x to the power of 1 over 2, that's square root of x. Then it's having cube. You know it is 3 times 1 over 2. Yes. So do you understand it now? Yes, alright. So that is just that about that. So please screenshot, then you take the remaining one as assignment. Take the remaining one as assignment. You take question 5 and 6 as assignment. Princess, what happened? I don't want you to waste the you spend it each amount of data. Why is it 3x? Oh, 3x. Azal, why is it x to the power of 1 over 3? Or what? Amira, what are you asking? Why is it 3x? It's not 3x, it is x to the power of 3 over 2. The 3 over 2, the 2 comes up, the 3 stays down. So the 2 comes up, the 3 stays down. But the x to the power of 3 over 2, sure you get x to the power of 3 over 2 now becomes 3 times 1 over 2. That's 3 times, it's still the same thing. Sure you get. It's still the same thing. Please explain number 4. Okay. 3 times. Okay, how is it? And now 3 over 2 is the same thing as 3 times 1 over 2. 3 over 2 is still the same thing as when you have 3 over 2 now. I'm coming, I will explain it again. When you have 3 over 2, it's still the same thing as 3 times 1 over 2. Just by separating it. 3 times 1 is still 3 over 2. Just by separating it. Sure you get. So just by separating it. So when you now have to the power of half, it is square root of that thing. So that's square root of the x. Then the cube is still there. You get it? So let me explain question 4 again. So we have integral of square root of x in respect to dx. We cannot integrate like this because it's in square root. You cannot integrate when your x is in fraction or your x is in square root. You can't integrate. So you have to first look for another way to write it. Another way of writing square root of x, that's what we just did now. That when it is raised to the power of 1 over 2, it is square root of x. So it means another way of writing this guy is x to the power of what? That's x to the power of 1 over 2. Do you get it now? That's x to the power of what? 1 over 2. Are you getting it now? Are you getting it? So it means that what? What do we now do? Integration is add 1 to the power over the power. What is that the power? 1 over 2. Just add 1 to it. Over that same power, which is 1 over 2 plus 1. Do the LCM for this 1 over 2 plus 1. When you do the LCM is 2. 2 in 2 is 1. 1 times 1 is 1. Then plus here is over 1. 1 in 2 is 2. 2 times 1 is 2. 1 plus 2 will give me 3 over 2. So it means that will be x to the power of 3 over 2 over 3 over 2. Are you getting it now? So what do you now do here? This guy, this 2 goes up, the 3 stays down. It's just like, you know, it's divided by 3 over 2. You know, when it is x to the power of 3 over 2 divided by 3 over 2. That's what you have here, divided by 3 over 2. When you now change it to x to the power of 3 over 2 multiplied by, when you change it to multiplication, from division, you change it to multiplication. Wait, no, that's not all. That will be 2 over 3. 2 goes up, 3 comes down. Wait, don't go yet. We have indefinite. We have definite. Wait, don't go yet. So, oh, sorry. So that will be 2. Oh yeah, down. I'm explaining fast. That will be 2 over 3. That's how you have it as 2 over 3. Then this 3 over 2, I told this 3 times 1 over 2. Then square root of x cubed. My people are complaining their data, I beg. That's just it now. It's not hard. Oh yeah, please, screenshot. Then you take number 5 and 6 as assignment. Take question 5 and 6 as assignment. Let's do the last thing and we'll call it a day. Yes, please wait though before you go. Wait though. Let's do the last thing and we'll call it a day. Oh yeah, can I clean? Can I clean? Yes, definite. Wait though. If you have not, wait and let's do definite. Can I clean? Can I clean? I know it's sucking data, even further than TikTok, but please just wait. Yes. There's no bar. There's no no. Alright, I'm moving on to clean. Experience the call. Experience the clean. Alright, so the last one we'll do. I'll just solve 2 examples and we'll call it a day. Just 2 examples and we'll call it a day. 2 examples. So it is called definite integral. So it is called definite integrals. Definite integral. So it says find the integral of the following functions. Okay. Question 1 says integral 0 to 1 3x squared dx. Question 2 says integral 2 to 8 1 over x dx. Question 3 says integral 2 to 4 1 over x squared dx. Then question 4 says let me stop there. Let me just stop at question 3. Integral 2 to 4 1 over x squared dx. Let me stop here. Now let's solve. I'll solve 2. Solution. I'll solve 2. I'll give you the last one as assignment. Question 1 says integral 0 to 1 3x squared dx. Now look at this question. Yeah, no constant is needed. Alright, so thank you everyone. Thank you so much. Let's solve. I'll solve 2. I'll give you the last one as assignment. So now, let's look at this guy. Now, this is under definite integral. Find the integral of the following functions. Now, you see that this is a definite when it has a limit. Lower limit. This is called the lower limit. This is called the what? Upper limit. This is called the lower limit. Why this is called the upper limit? Lower limit, upper limit, lower limit, upper limit. Are we all good to go? Are we ready? Alright, yes. So look at question 1. You see the normal procedure. You know, when you want to integrate 3x squared, you know, 3 will come outside, then I'll be left with x squared dx. Then 0 to 1. Do you all agree with me? Look at this guy. The dx means I'm integrating in respect to x. It means anything apart from x is a constant. So what will come outside here? 3 will come outside. Then I'm left with x squared dx. Okay, alright. So now, integrate x squared. What do you have? When you integrate x squared, what do you have? That will be 3 into bracket x to the power of what? That will be 2 plus 1 over 2 plus 1. So that will give us 3x cubed over 3, right? Yes, that's x cubed over 3. So 3 cancel 3, so we are left with x cubed. So it's 0 to 1. Don't forget it has a limit. Oh. What is the limit? 0 to 1. So when you have integrated normally now, you see that you will not add plus c to your answer. Do you see that plus c will not be added to the answer, right? So can we get it? See that plus c will not be added and the limit is 0 to 1. So what do? You put for the upper one first. You know we integrated in respect to what? We integrated in respect to x, right? So you put for the upper one. What's the upper limit here? What's the upper limit here? The upper limit here is what? What's the upper limit here? The upper limit is what? 1. So that will be, anywhere I say x, I put 1. That will be 1 cube. Then when you want to put for the lower limit, you subtract. When you want to put for the lower limit, you subtract. Then that will be what? 0 cube. 1 cube will give me 1. Minus 0 cube is 0. 1 minus 0 is what? 1. And the final answer is 1. Do we understand it now? So you put for, after you've integrated normally, you put for the upper one first, then subtract and put for the lower one. Do you get it now? Are we all clear? Are we all clear? Wow, yes, that is just that about that. Are we all clear? Alright, let me solve question 2. For question 2, what does question 2 says? Integral 2 to 8, 1 over x dx. Now, whenever you integrate 1 over x, if you are told to integrate 1 over x in the exam, what will you have? Integral, re-explain 1 cube minus, you put for the upper one first, upper limit. Anyway, you integrated in respect to x, so you put the limit in respect to x. So the upper limit is what? 1. You put it in, anywhere you see x, that's 1 cube minus 0 cube. And that 1 cube is 1, 0 cube is 0. No, favor, you've made a mistake. You've made a mistake. It is not x. Though I said you cannot integrate anything in fraction, truly, you were supposed to change it. But no, you know when you change it to x to the power of minus 1, no, you can't write it as that. Same form. If you change it as x to the power of minus 1, now when you integrate it now, that will be x to the power of minus 1 plus 1 over minus 1 plus 1. What is minus 1 plus 1? That will be x to the power of 0 over 0. X to the power of 0 is 1 over 0. That will give you infinity. It is wrong. It is wrong. It is wrong. So you can't change that one to x to the power of minus 1. I told you now, hey, even arrow word self. Arrow word, when you integrate 1 over x, what do you have? Arrow word, all of you that started, you see, it is Linux now. Where do you put your brain? Are you eating or what? I gave you that. I gave you is a formula. Is a formula. I gave you the formula that when you integrate 1 over x is what? Oh, you're not servicing. Oh. When you integrate 1 over x, that gives us the x. So what is the boundary? 2 to 8. So you put for the upper one, then subtract. That will be ln. You know, is anywhere you see x, the chop this. Anywhere you see x, you put the upper one first. That will be ln 8 minus ln 2. What does it mean? It means ln 8 over 2. According to logarithm. You know ln is the same thing as logarithm, right? How many of you know ln is the same thing as logarithm? Right? You know ln is the same thing as log base e, right? Yes. Ln is the same thing. So, you know, according to logarithm that says when you have log a minus log b, log a minus log b will give you log a over b. You know, when is division, when is minus, it becomes division, right? Right? Are you guys following? So when is minus, it becomes division. So that will be ln 8 over 2. So what will be our final answer? Our final answer will be ln 4. Ln 4. Ln 4. And that's the final answer. And that's the final answer. So on this, we call it a day. On this, we call it a day. A big shout out to everyone in the house. A big shout out to everyone in the house. Thank you everyone for coming. Thank you so much for coming. Thank you. Please make sure you go through it again. Make sure. So how do you get it in? It is a formula now. It's part of the formula I gave you. It's part of the formula I gave you. So let me show you where you could watch the video before you go. Alright, wait, let me show you where you could watch the video. That's all. You take the third one as assignment. Now, if you want to solve question 3, what do? You know you can change this one, Abby. If you want to solve question 3, what do? What do you do to question 3? If you want to solve question 3, alright, no problem. If you want to solve question 3, you know you first write it now. Before you go, wait. If you want to solve question 3, you know you first write it, right? So when you write it, alright, people, listen first before you go, wait. If you want to solve question 3, it's not in x square. No. Question 3 is not in x square. It is x to the power of minus 2. It is x to the power of minus 2. So you will write it. It is only when you have 1 over x, integral of 1 over x, that gives you in x. But when it is 1 over x squared, you change it to what? That will be integral of 2 to 4. That will now be x to the power of minus 2. So it's only that you cannot call it in x squared. Sure you get. Yes, question 3 answer. It's not in 4. If you like, go do another thing. It's not in x squared. Don't call it. It's not the same thing. Don't call it in x squared. It's not the same thing. Do you understand? Do you understand what I just said now? So let me show you. Yes. So let me show you where you watch the video. Let me show you where you watch the video. So when you go to my TikTok page, alright. So when you go to my TikTok page, look at it. You see these 3 pin videos, ba? These 3 pin videos, can you see it? Alright. So you see this playlist. You see this thing I'm moving. This playlist. This thing I'm moving is a playlist. So, alright. So swipe it to the left. Just swipe. You see this playlist. Swipe it to the left like this. Just swipe it. You see view all. I'm rounding up already. When you see view all, click on view all. See view all. Click on view all. Still limit and continuity. If you want to learn it, fine. Or if you don't want to learn it, leave it. This is differentiation. Don't worry, I'll move integration up after I'm done. See integration here. Just look for integration. But don't read everything, though. Don't read everything, though, because there are some things there that you don't need. So don't read everything. So this is the formula. For those that missed the formula, this is it. You can watch the formula here again. Look at it. So why these are the indefinite integral? This is the indefinite integral. The questions on indefinite. But don't watch all these ones. So all these techniques used in solving integration, don't watch it. Don't watch all these techniques. Don't watch it. Leave it. All these techniques, don't watch it. You don't need it. So why this is under definite integral? Why this is under definite integral? So these are the picture of f. You see when you integrate 1 over x, do you see that it is ln x? Can you see that it is ln x? But we add plus c to it because it doesn't have boundary. Have you seen the integral? So this is the table in case if you want to learn. Sure you get. So this is the pictures of everything in case if you want to watch it. So please make sure when you watch, you share. Make sure when you watch, you share. Don't worry, after the live, I will move integration under differentiation so it will be better. So this is limit and continuity for those that want. This is differentiation. Then we have matrices and determinants, inequality, AP and GP, polynomial, quadratic equation, set theory, logarithm, indices, number system, fundamental and derived quantities for those that need physics. If you want fundamental and derived quantities, it's here. Fundamental and derived quantities. So they are all here. So you can watch it. And conversion, for those that don't know how to convert SI units, it is here also. So please make sure when you watch, you like and you share. Like and share, repost, like and share and repost. Alright. Like and share. How we go take one now? Which one? Just solve it now. Like and share and repost. So thank you everyone. Take care of yourself and have a good night rest. Thank you everyone for the tabs. Thank you for coming. Yeah. Rachel. Thank you. Hero World, Rachel, Favor Princess. I can see you. Before you go, when are we doing angles? So tomorrow we'll just go for trigonometry. Yeah, tomorrow we'll just go for trigonometry. Tomorrow we'll go for trigonometry. So Amarachi. So say something before you go. Say something, Prof. Alright, Manuel Adebowale, thank you. When are we doing angles? Tomorrow, Amarachi. Tomorrow, same time, 9 p.m. Don't come late. 9 p.m. So say something before you go, or if you don't want to say anything, roll the heart, drop your favorite emoji before you go. Just drop something and go. Drop your favorite emoji before you go. So please drop. Thank you. All right. Thank you everyone. Amira, thank you. Pullman, thank you. Rodia, thank you. Euroworld, thank you. Thank you. I beg. Yeah. Tomorrow, yeah. All right, Adeboale, thank you so much. Thank you. Delight, thank you. Amachi, Rodiat, Delight, Princess. Princess, you're giving me pick as now. May your guy no good catch me, I beg you. All right, thank you everyone. Thank you. One Bernard, Amachi, thank you. Rachel, thank you so much. All right, go. We appreciate. Okay, Ilinera. All right. Thank you. Shinfon. All right, go. Yeah, start going. Pack. Go. Let me be the last person here. Yeah, pack. Be going. Pack will be going. All right. Go now. All right, bye. Good night. Ilinera. Bye. Chiffon. All right, bye. We want here. You better go. Go, I beg. Good night, Amira, good night. Go. Oh yeah, all of you be going. Go. Go. Leave. Good night. Sunday. Victoria, good night. Good night. Delight, good night. Cool now. Richie, good night. Alright, Richie. Good night, Amira. People are telling me good night. Go now. Very good. Ivana, thank you so much. Prof Kay, what are you saying, Emmanuel? What are you saying? You wanna go now? I'm tired for now. Must you sleep here? So I beg, sleep well. Alright now, thank you. Thank you so much. Who don't want to go? Me, I'll be going. Be going. We are 17 people. We are go. Go now. It's not like I'm going to do anything when you go. Hey, it's my bye. Good night, everyone. Take care of yourself. Have a good night rest. Bye. What's your question? I'll talk now. Yeah, what's your question? What's your question? Yeah, what's your question? Alright everyone, good night. Take care of yourself and have a good night rest. So since you don't have any question, take care of yourself. You will not put it in decimal. So you don't have any question. Alright, good night. You will not put it Samuel Prince, you will not put it in decimal. You will not put it in decimal. So good night everyone. Take care of yourself and have a good night rest. So bye. For which question 4? Question 4. Is it question 4 or question 3? Which one? Question 4 or question 3? Which one? Question 3. You will leave it in decimal. Don't have. You leave it in decimal. Alright, no problem. You leave it in decimal. I say decimal. You leave it in either it is in fraction or anything. You leave it in fraction. You don't write it in. You don't put it in decimal. You leave it in fraction. Leave it in fraction. So alright, take care of yourself and have a good night rest. Bye.